Hello everyone. In this video, we'll be talking about trigonometry. In the last few videos, we were discussing various different concepts of trigonometry, like trigonometric ratios for special angles, and trigonometric identities. But the one question that would have lingered your mind is, where do we have to use this trigonometry? How do we use this trigonometric rules in our real life? So let's look into this today's video to understand how trigonometry is important and why it is important to understand the basics of trigonometry and where all it is used in real life. So how trigonometry is helpful to us in real life, we'll just have a quick 2-minute understanding and then we'll go into the concept. Okay. So where do we use it and how to use it is what we are going to get a understanding about in today's video. Okay. So trigonometry basically used into three main categories. One is constructing maps. Okay. The latest map, the satellite based technology, the GPS system that you all have in your mobile phones, the Google Maps. Somewhere these technologies are being developed based on using trigonometry. The olden days map books that you have was constructed using trigonometry. The distance between planets, the distance between different celestial objects, the distance between sun and moon, the distance between earth and moon, everything was being calculated using trigonometry. And length of the shadow can also be calculated using trigonometry. One of the major uses of trigonometry is nowadays high-rise buildings are being built. Even before building it on paper, how to build it, what kind of uh, the material that should be used because of the based on the height, how strong it should be, because the more the height the object goes, the more it is going to come under natural natural obstructions like wind, heat, and the depth of uh, the base of the tower or base of the building so that it can withstand these natural changes. At the same time, as the height of the tower goes higher and higher, the stability, the strength should also maintain. So these all things are being calculated using trigonometry, and a clear idea comes into picture what structure, what shape will hold on to the structure. Okay. So trigonometry we just saw in three different phases right now, but there are many different uses. So the first concept of trigonometry, the first thing that you should know is the meaning of the word elevation. As you can see here in this picture, there is a sideway which is allowing you to walk towards the upward direction, towards the tunnel. The building is raised higher, right? And the staircase. What does this picture depict? The elevator in this building allows to move up. What is an elevator? The meaning of the elevation is raising high above a given height. What does the elevator do? It helps you to go up, right? You have your escalators. They also help you to go up. Staircase, they help you to go up. So why we are understanding why do we need to understand the meaning of elevator? No, we are trying to understand the meaning of elevation. Why? Because this is one of the key concepts that will be applied in real life situation. So as you can see here, there's a picture wherein a girl is standing in the balcony of her hotel room and she's looking at the, yes, Eiffel Tower. So first of all, when the girl is looking straight, and whenever you or me or any person sits straight and having a straight vision, that is called as the line of vision, which is always there. So when you look above to any object, it can be to the clouds, to the ceiling fan, to the tower top, okay? Or you're standing on the road and looking at the terrace of your house. Similarly, this girl is looking at the top of the Eiffel Tower. So the line that is formed when she looks above, automatically your eyeballs move towards the upward direction. So that line is called as line of sight. So the angle that is formed between the line of vision and the line of sight is called angle of elevation. Did it move upward? What was elevation? Raising above the height, given height. What is the normal line of sight? Straight. So when you look above, your eyeballs automatically move upward. That is line of sight. So the angle between the line of sight and line of vision is called angle of elevation. Let's have few examples to understand angle of elevation. So when you fly a kite, like this tiny little boy is trying to fly a kite, where do you look? You look towards the sky. So again, the angle of elevation is when you're looking towards the sky, that is line of sight and the line of vision, right? Are these two examples coinciding? Yes. Let's look into the next. So when you or any person is standing on the street and looking up to a window or a terrace, if a person is standing there. Suppose a person is standing in this terrace and the other person is standing on the street and he's looking up and smiling. So again, looking up. So angle of elevation. So if you look in all these picture, the eye direction is towards the upward, right? And suppose you're standing in a hotel room or in your office room and you're looking at the top of the most tallest building near your office premises. So again, you are looking up. That is angle of elevation, right? So let's look into few questions based on angle of elevation. So how are we going to use it? We'll give an explanation in each type of question that we'll be looking into. Okay. So can you see the first question? They're saying that a tower of 100 square root 3 meters high. So the height of the tower is 100 square root meter. So it's 100 root 3 meter. Okay. We need to find the angle of elevation. If its top from its point, from a point is 100 meter away from its foot. So the top is away. So when you are angle of elevation means you are standing on the ground. Okay. So you are how many feet away from the foot of the tower? It's 100 meters. Right. So we need to find it. What? The angle of elevation. So we have to apply the trigonometric rule here. So if you see, this is the opposite, this is the adjacent, and this is the hypotenuse. So right now, I have been given the opposite and the adjacent. So which trigonometric rule will be applied here? Let's take use of it. Before that, we have to label the triangle. So let's say that this is P, this is Q, and this is R. And we have to mention which side is which. So PQ is representing the height of the tower. Okay. QR is representing what? Distance between base of the tower and the observer. Okay. So PQ is height of the tower as I've listed here. QR is distance between the observer and the base of the tower. Okay. Q, the observer is here at the point R, and theta is the angle of elevation. We need to find the angle of elevation. So as I've already mentioned, O is a PQ, that is the opposite side, and adjacent side is QR. So which trigonometric ratios do you think will apply here? Yes, it's going to be tan. So tan theta equal to opposite upon adjacent. So it's PQ upon QR, right? PQ is 100 root 3 divide by 100. So the 100 and the 100 gets cancelled off. You will get tan theta equals to root 3. Which angle of tan is square root 3? That we have to mention. So tan theta is equal to tan of 60. So tan gets cancelled off, right? And we'll get theta equal to 60, right? So we cannot directly use any other method to find the angle of elevation except trigonometry. Okay, let's take the next question. So as you can see here, the question says the angle of elevation of the top of the tower from a point on a ground which is 30 meter away. The point on the ground is 30 meter away from the base of the tower. So here the base of the tower, which is far away from the point, how much far? 330 meter, is represented by BC. So BC is the distance between the observer and the tower, and that is given as 30 meter. Okay, the height of the tower is AB, which we have taken as H. The angle of elevation is 30. So let's mark the opposite adjacent. Okay, so the opposite side is this one, the adjacent side is this one, right? So again here we are going to use tan. So tan 30 degrees is equal to AB upon BC. So tan 30 is 1 over square root 3 is equal to H upon 30, right? So let's shift the 30 on the other side. So you'll get 30 upon square root 3 is equal to H. So we'll do the rationalization and we'll get our answer. So when you do the rationalization, it will be 30 root 3 upon root 3 equals to H. The root 3 and the root 3 gets cancelled. Sorry. 30 root 3 upon root 3 times root 3. Mistake. Is equals to H, right? So that will turn out to be what? 30 root 3 divided by 3. Okay, so the height of the tower, that is H, is equal to 30. No, the 3 and the 30 will cancel and get a 10. So 10 root 3, right? So what will be the last sentence? Because it's a word problem, so we need to write the last sentence. That will be height of the tower is equal to what? 10 root 3, not 30, 10 root 3 meters. Correct? Let's take the next example. A string of a kite. I hope all are used or all have flown kite. So string of a kite is 100 meters long and it's make an angle of elevation or angle 60 degree with the horizontal. So find the height of the kite. So if the string of the kite is tied on the ground to a particular point, okay, with the rod, then it will make an angle of 60 degree with the horizontal. So that is what they mean to say here. So automatically here the AB is the height of the kite, okay. AC is the length of the string, which is given to be 100 meter. So in this case, H is actually the opposite side and 100 meters is the hypotenuse. So which trigonometric ratio we'll be using here? Opposite upon hypotenuse? Yes, sine 60 is opposite, which is AC divided by AB. Sine 60 is root 3 by 2 equal to AC is 100, sorry, H. I've written the wrong name here. I'm sorry, AB by AC. Mistake, sorry, opposite upon hypotenuse. Yeah, so it's H upon 100. So let's shift the 100 to the other side, right? So that will be 100 root 3 divided by 2, which is a H. So 150 will cancel, sorry, 2 will cancel and you get 50. So height is 50 root 3. So what's the final answer? Height of the tower. No, height of the kite is 50 root 3 meter. Right? Clear? So this is how the trigonometric rules or ratios and angles of trigonometry are used in real life example. In the next coming videos, we'll be talking about further more examples. So angle of elevation is the focus, and based on angle of elevation and the trigonometric ratio angles, we'll find the answer for the questions in the further different videos that we'll be looking at. Hope the concept of angle of elevation is clear. Thank you.